So, have you seen how often people fall into the trap of over-engineering during refactoring? It's like they want to solve every possible future problem instead of just fixing what's broken now.
Yeah, it's like they're trying to build a spaceship when all they need is a bicycle.
Exactly. And then there's the opposite issue, where someone barely touches anything because they're scared to make any significant changes. That's when you end up with spaghetti code that nobody wants to touch.
I've been there. Sometimes you just don't know where to start, so you do nothing at all.
Which leads to another anti-pattern, avoiding technical debt altogether by never making improvements. You know, the "it works, let's leave it alone" mentality. But eventually that catches up with you in a big way.
True. True. Especially when new features pile on top of old code without any cleanup.
Absolutely. And then there's the whole issue with code reviews. Some teams skip them entirely or rush through them. That can be a recipe for disaster, because no one double-checks if the refactor introduces new bugs or doesn't address the original issues properly.
Right. And sometimes reviewers get too nitpicky about formatting rather than focusing on functionality and logic.
That's why having clear guidelines and expectations up front is crucial. Otherwise, everyone gets bogged down in minor details while missing the bigger picture.
Definitely. Clear communication helps a lot in those situations.
Speaking of which, over-engineering and architectural complexity can be even trickier. Have you ever worked on a project where the architecture was so complex that it became hard to understand?
Oh yeah, I've been there. It feels like navigating a maze without a map.
Exactly. People often add layers of abstraction or design patterns that aren't really necessary just because they think it makes the system more robust or scalable. But in reality, it just adds unnecessary complexity.
And debugging becomes a nightmare when you have to trace through multiple layers of abstractions.
True. Plus, it can lead to maintenance issues down the line. New team members might find it difficult to wrap their heads around the architecture, leading to slower development cycles.
Absolutely. Simplicity should always be the goal unless there's a clear reason why added complexity is necessary.
Agreed. It's important to balance between flexibility and simplicity. Adding too much upfront thinking can sometimes hinder progress rather than help it.
Definitely. Finding that sweet spot isn't easy, but is definitely worth striving for.
For sure. And sometimes it requires revisiting decisions as you learn more about what your application truly needs over time. Speaking of architectural issues, tight coupling between modules and classes is another common pitfall. Have you ever worked on a system where changing one module required updating several others?
Oh yeah. It's like pulling one thread and unraveling the entire sweater.
Exactly. When modules are tightly coupled, it becomes extremely difficult to modify or replace parts of the system without affecting others. It's like building a house where moving a wall requires rebuilding half the structure.
And testing becomes a nightmare because you can't isolate components easily.
Absolutely. Loose coupling allows for better maintainability and scalability. Each component should ideally function independently so that changes in one part don't cascade through the entire system.
That makes sense. It's easier to debug and test individual pieces when they're loosely coupled.
Definitely. Design patterns like dependency injection can help manage dependencies and reduce coupling, but it does require careful planning from the beginning.
True, but it pays off in the long run.
For sure, the key is to strike a balance between loose coupling and practical implementation. Too much decoupling can also add unnecessary complexity. Another issue that pops up frequently is the excessive use of global variables. Have you ever seen a codebase where everyone relies heavily on globals?
Yeah, it's like trying to keep track of everything in one big notebook. It gets messy fast.
Exactly. Global variables can lead to hidden dependencies and make it hard to predict what a piece of code will do based on its local context. Debugging becomes a real challenge when any change can affect something far away.
And it's tough to write unit tests when functions depend on global state rather than explicit parameters.
Absolutely. Encapsulation is key here. By limiting the scope of variables and passing data explicitly through function arguments, you make the code more predictable and easier to test.
Makes sense. It's all about reducing side effects and making the flow of data clear.
Definitely. While global variables can seem convenient at first, they often lead to maintenance nightmares down the line. It's better to opt for more controlled ways of sharing data, like using well-defined interfaces or services.
Agreed. Clearer boundaries mean fewer surprises.
For sure. The goal should always be to minimize global state and ensure that each component operates within a well-defined context. Speaking of common pitfalls, premature optimization is another one that trips people up. Have you ever seen developers spend hours optimizing code that wasn't even a bottleneck?
Oh yeah, it's like spending days polishing a car door handle when the engine is the real problem.
Exactly. Premature optimization often happens when developers jump straight into fine-tuning performance without first identifying actual bottlenecks. It can waste a lot of time and effort on areas that don't really matter.
And it can make the code harder to read and maintain in the process.
Absolutely. The best approach is to profile the application first, to find out where the real performance issues lie. Then focus your efforts on those specific areas.
Right. It's all about measuring before optimizing.
Definitely. It's important to prioritize clarity and correctness over micro-optimizations until you have concrete evidence that certain parts need tweaking. Profiling tools can provide valuable insights that guide effective optimizations.
Agreed. It's better to have clean, understandable code that performs well where it matters most.
For sure. Optimizing prematurely can lead to overly complex solutions that obscure the intent of the code and make future maintenance challenging.